We're going to continue our study in quadratics today by talking about solving by factoring. So the first type of factoring that we're going to go over is factoring out a GCF. So when you're factoring out a GCF, you're going to find the largest term that divides evenly into each term in the expression, and then write what is left over in parentheses. Then you're going to set each factor equal to 0 and solve for x. All right, here's our first example. We have 5x cubed minus 15x squared equals 0. We're trying to solve by factoring out the GCF. So we have two terms here, 5x cubed and 15x squared. And between those two terms, we want to find the largest factor that will go evenly into both. So in this case, it looks like they have a 5 in common and they have an x squared in common. So I'm going to write 5x squared out in front. And then in parentheses, we're going to write down what's left. So after factoring out 5x squared, we're going to be left with x for the first term. And for the second term, after taking out a 5x squared, we're left with minus 3. All right, so we're going to set each of those factors equal to 0. So 5x squared equals 0, and x minus 3 equals 0. And then we'll solve for x. So in this first one, we divide both sides by 5. That leaves us with x squared equals 0, which is then x equals 0. And then for the second one, x minus 3 equals 0, we're going to add 3 to both sides, and that leaves us with x equals 3. So for this example, our answer is x equals 0 and x equals 3. All right, next, we're going to factor by splitting the middle. All right, so this is when you have 3 terms. And when you have 3 terms, you're going to split the middle term into 2 terms that multiply to a times c and add to b. Once you've found those, you're going to split the middle, and after splitting the middle, you will group the terms, factor out a GCF, and then set each factor equal to 0 and solve for x. All right, so let's take a look at an example of this. We have 2x squared minus 3x minus 9 equals 0. So 3 terms. I'm going to draw an x over here just to keep track of what I'm trying to find. I'm trying to find 2 numbers that will multiply to a times c. That would be 2 times negative 9, which is negative 18. I'll write that up on top. And that will add to negative 3. We'll put negative 3 down here. All right, so finding a pair of numbers that will multiply to negative 18 and add to negative 3. So that's going to be negative 6 and positive 3. So now what we're going to do is we are going to split that middle term, the negative 3x, into negative 6x and positive 3x. So let's write that out. We have 2x squared minus 6x plus 3x minus 9 equals 0. All right, so now we're going to factor out the GCF from the first 2 terms, and then factor out the GCF from the last 2 terms. So in the first 2 terms, we can factor out a 2x, leaving us with x minus 3. And in the last 2 terms, we can factor out a 3, leaving us with x minus 3. Now, if you've done this correctly, what's inside the parentheses should always be the same. So that leaves us with 2x plus 3 and x minus 3. Now we're ready to set each of those factors equal to 0 and solve. So 2x plus 3 equals 0, and x minus 3 equals 0, and solve. So we have x equals negative 3 halves from the first equation, and x equals 3 in the second equation. So those are the 2 answers for this example. All right, next, we're going to talk about how to factor a difference of squares. All right, so when you have the difference of 2 terms that are both perfect squares, that's when you're going to be using this method. Okay, so it has to be a difference of two terms, and those two terms must be perfect squares. And then you'll take the square root of each of those perfect squares, and in one parenthesis, you'll have a positive, and in one, you'll have a negative. So we'll just put a plus in one and a minus in the other. And then you will, just like we've been doing for the other problems, set each factor equal to 0, and then solve for x. All right, so for example 3, we have 4x squared minus 25 equals 0. We can see here we have a difference of perfect squares because 4x squared, if we take the square root, will come out evenly, and same with 25. So what we're going to do is we're going to put in our two parentheses that we're expecting here. We're going to take the square root of 4x squared, that's 2x, and I'll write that as the first term inside both parentheses. Next, we're going to take the square root of 25. We're going to ignore the minus for now. And the square root of 25 is equal to 5. So I'm going to write 5 as the second term in both sets of parentheses. All right, so now we have two sets of parentheses. Now the only thing is that one has to be positive and one has to be negative. So we're going to put plus in one and minus in the other. All right, now we're ready to set each of these factors equal to 0. And then solve. So 2x plus 5 equals 0, and 2x minus 5 equals 0. All right, solve for x. So we end up with x equals negative 5 halves, and x equals positive 5 halves. And those are my answers for this problem. All right, the last type of factoring we're going to do is factoring by grouping. So this is when you have four terms. And what you want to do is you want to split the expression into two smaller groups of terms and factor those groups by their GCF. What's left over should be identical within both parentheses. Once you have them in factored form, then you're going to set each factor equal to 0 and solve for x. Great, let's look at our last example here. X squared minus 4x plus 3x minus 12 equals 0. So we see here we have four terms. What we're going to do is we're going to group the first two terms together, so x squared minus 4x, and then the last two terms together, 3x minus 12. We're going to factor out the GCF in each group. So in the first group, we're going to factor out an x. In the second group, we're going to factor out a 3. So we're going to be left with x times x minus 4. And then in the second grouping, we said we would factor out a 3, leaving us with x minus 4 inside the parentheses. And now we can write it in factored form. So in factored form, that would be x plus 3, and then x minus 4. And now we can set each of those factors equal to 0 and solve. So x plus 3 is equal to 0, and x minus 4 is equal to 0. Solve both of those, so we end up with x equals negative 3 and x equals positive 4. And those are my two answers for this last example.